Hello and welcome to FX PhD. This is Max 201. This is going to be our second Max class we've ever done at FX PhD. This one is specifically called Advanced Rendering and Mental Ray, and I hope that's why you've downloaded this QuickTime file and are interested in the Mental Ray rendering engine. Something that's come up in the forums that's been asked already prior to the class even getting started is it applicable to other applications? Now what I mean by that is Mental Ray is sort of a plug-in renderer, and it's included with a couple of different applications out there. The biggies that are using it right now are Autodesk Max and Maya, as well as Softimage XSI, and those are the three that actually ship with a license of Mental Ray. And while this class is Max 201, it's going to be very specific to Mental Ray. So, take that with a grain of salt. This is a Max class, but we're going to be focusing on the Mental Ray rendering engine and things like shaders and light types and things very specific to Mental Ray. So while you might be using a different application other than Max, it will be a class specifically addressing Autodesk 3ds Max. Now, I thought I'd start out with a little bit of history about Mental Ray, and not so much a history historically, but just talk about what is Mental Ray. A lot of people that might be using Mental Ray or have access to it aren't exactly aware that it is actually made by a separate company than, say, Autodesk or Avid. Mental Images is the name of the company that makes Mental Ray, and it is actually a third party. They are completely apart from Autodesk and Avid and all the other developers. They're a German company, and you can see that they have a lot of other products here. I'm going to go in specifically to Mental Ray and just point out that their website is a host of good information here. For example, is a PDF that I would encourage everybody to go download, and there's also a lot of great things in the gallery. Now, I'm not going to handhold you through this entire website or anything by a long shot, and I encourage you to do so on your own. But one of the things I wanted to show you is the history of Mental Ray. It's one of the two, I would say RenderMan and Mental Ray are really the two predominant rendering engines for visual effects out there. And we can use Mental Ray for a lot of different things like architecture and whatnot. But visual effects is kind of the slant we'll be addressing for the most part. However, when we get into outdoor lighting, that will certainly be an architectural sort of exercise. Now you can see here there's a lot of work over the years that has used Mental Ray, and companies like ILM and Buff Company in Paris, Digital Dimension, Glassworks, Hydraulics, and ESC have used this for a lot of other companies too. This, by the way, is my favorite movie of all time, City of Lost Children. Mental Ray has been used for a lot of different things over the years, and it's been used in a lot of different places. I just wanted to give you a bit of a background on there and encourage you to go check out Mental Images' website. I'm also, by the way, going to be providing you a lot of different URLs in a text file that will be accompanying this class. Another website rather, to go check out is Autodesk.com. And this is pointing into the products area specific to Mental Ray. Now you can see here they've got a little bit of work to do on their new website, evidently, but there are some resources here about frequently asked questions and things specific to Mental Ray. One of the things I want to talk about, or to make clear in this beginning class, is that there are a couple of different ways of running Mental Ray in any program. You can see here there's a standalone license of Mental Ray available. Now, to be clear about this, we will not be addressing the standalone version. What we're going to be concentrating on is using Mental Ray inside of 3ds Max 9. And another thing that we're not going to be doing in this class, just to be clear, we're going to be addressing Mental Ray for artists. This is not going to be a class designed for programming shaders or anything like that for technical directors or anybody interested in actual like C++ programming of shaders. So for you programmers, I'll admit that this is not the class for you. However, for the artists in the audience that are listening to this and watching this Camtasia, this is actually going to be the class for you. This is going to be transitioning from the scanline renderer using 3ds Max and actually taking hold of and really embracing Mental Ray. I can't tell you enough how excited I am and how much Mental Ray has come along with the advent of 3ds Max 9. One last website that I'd like to actually share with you this week is one of the great companies out there using Mental Ray, and this is Buff in Paris. They've been using Mental Ray for many, many years for commercials and feature film work. And again, I'm not going to handhold you through their entire website either, but I would really encourage you to go check out the long history of great work that they've been doing over the years with Mental Ray. So buff is a really outstanding one, another one, Digital Dimension. And just to reiterate, I am going to be providing you with a lot of different links of mental ray resources, other forums, websites, and companies that are using mental ray. Now, one of the things, just talking about mental ray a little bit and how it affects your projects and what this class is really going to be about, is inside of 3ds Max, the main three areas that are affected are materials, lighting, and rendering. And that's basically what mental ray is all about. What this will not be is a class for modeling or rigging or animation per se. Now, we will be doing animation and we will be rendering animation, but this is going to be focusing a lot on materials, lighting, and rendering, and that's why hopefully you're here to take a look at those features inside of 3ds Max. So jumping into 3ds Max, and right now, for the record, we're going to be running 3ds Max 9. Service Pack 1 recently came out as of the time of this recording, and if you haven't downloaded the Service Pack for Max 9 yet, I would encourage you to do so. However, getting back into the Max specific things, this week what we're going to be taking a look at is sort of transitioning and switching your application into sort of the mental ray mindset. We're also going to be taking a look at the default switcher and a way to do that so that Max will launch every time sort of ready to work in mental ray. We'll also be taking a look at a phenomenal feature that ships with 3ds Max called distributed rendering, and this is a way to basically take advantage of multiple computers on your network. For network, it's kind of like network rendering, and technically it is a form of network rendering, but as you'll see in a moment, it's a really exciting way to accelerate the process of building a scene and not only rendering the final project. And lastly, this week, what we'll be closing out with is really just taking a look at the render dialog and a lot of the real big picture stuff about rendering and mental ray. Next week, we'll start our foray into the shaders, and we'll be that'll be actually a 2 or if not 3-part look at shaders. There's obviously a lot of stuff before we even get into rendering and lighting. But again, to bring it back to this week, what I wanted to do was just talk about a scene, and this is just a scene. I'd like to thank Marlin Studios for providing this file here. But this is basically just, you can see here, kind of a spooky haunted mansion here. And it's on an island, and what we've got is basically a scanline scene. And you can see here, if you're familiar with 3ds Max and you've been using it for any number of years, the scanline renderer. And before I even start talking about mental ray, I'm not going to be bashing the scanline renderer here. There are very many good uses still for this scanline renderer. To be clear about this class, it's just a transition to mental ray, but that's not to say that mental ray is a substitution for the scanline renderer. And I'm going to try to point out differences in, between the two and when you might want to think of one over the other. That'll predominantly be in materials, well, actually materials, lighting, and rendering. There will be reasons and advantages to both. And I don't want you to dismiss the scanline renderer. It's still there. It's still being developed. There's a lot of great uses for it. So back to this scene right here, what we've got is a basic 3-point light setup, and it's certainly not, you know, the best work I've ever done in the world by a long shot. But what we've got is a basic scene set up and using scanline renderer. Now, if you haven't used mental ray, one of the points of this class is to dispel any sort of worries or angst about using this rendering engine. Hopefully after this session, you'll be really excited in using mental ray for a lot of different things and have the, you know, courage to look to it for different things. Now, if you bring up in Max the render dialog, under the common parameters tab, way down at the bottom here is where you can assign the renderer. Something that if you're going to be switching between mental ray and scanline, or even like V-Ray and Final Render or another third-party renderer, one of the things that I like to do is actually take advantage of the fact that you can reorder these menu items in Max. And that's true actually throughout the application, in both the command panel and the render dialog and the material editor and so on. This is just a little bit of a side note. But since I'm going to be adjusting and switching the renderer a lot, I want that to not be way down here at the bottom. So what we can do is roll this up, and I'm just going to drag and drop this right up at the top here so that now my common parameters still show up, but I can very easily assign a renderer right up at the top here. Now by doing this, I'm going to go into Assign Renderer, switch my production renderer to mental ray, and now the mental ray rendering engine is essentially loaded. If I go ahead and render this out, you're not going to see any like Academy Award winning change in this image. What's basically happened is that Max is now writing out a little file called an MI file, which is kind of Mental Image's own file extension or file format. And transparent to the user, and this is true of Softimage, XSI, and also Maya, is that the host application, your 3D software, converts all of the light data, all of the materials, all the shaders, everything in your scene to an MI file and sends it off to the Mental Ray rendering engine. And then Mental Ray does the rendering and then sends it back to the frame buffer. And in this case, in 3ds Max, I have a virtual frame buffer here. Now, something that I'll also show is if I bring up the Windows Task Manager, let's bring that into view. You can see here, way down here, there's this RaySat 3ds Max 9 32-bit server. I'm currently running the 32-bit version of Max 9, but this is actually a separate program running from 3ds Max. So Mental Ray is a different program running in the background, and there's a couple of different programs, but that's going to be one that you really want to, maybe potentially take a look at. So that's the basic switch of just enabling Mental Ray. And at this point, if I went ahead and saved this scene out, and let's call this, Sea Castle Mental Ray 01. Let's go ahead and overwrite that existing file. Now I have essentially the exact same file, and for all intents and purposes, this is really, there's no advantage or disadvantage to just using the Mental Ray engine. It's when and why you'd want to use its extra features like shaders and lights and caustics and things like that we'll be addressing in weeks to come. But this week really is just about getting your feet wet and switching you over into that Mental Ray workflow. Now, switching back and forth between the scanline renderer and Mental Ray is pretty much as easy as that. It's, again, just going into the render tab and switching your rendering engine for production. Something else to point out very briefly is that by default this is locked so that the material editor will actually use the same renderer, and that's probably a good thing. I would suggest leaving that. One of the things, and if you have been using Mental Ray, hopefully that's nothing new to you. Obviously, you've got to get to the Mental Ray engine somehow and somewhere, and that's typically how. However, there's a feature in Max that actually a lot of people have overlooked under Customize, and this is where you're going to set your hotkeys and things like that and load and save schemes. However, there's a thing called the Custom UI and Default Switcher, which is really often overlooked by a lot of users out there. So if I evoke this dialog, what happens is that Max is going to come up, and you can see here that there's an initial setting for Max. And again, I'm not going to read this entire thing to you. I would encourage you to do this as well. But you can see here that the overview is that Max is basically being set up to work with the scanline renderer. Lights are going to be set up, for example, to use shadow maps. The daylight system is set up to use a skylight, and so on. So Max, it basically sets up all the preferences. I don't really call them preferences technically, but it's all these settings within Max for specifically working in the scanline renderer. However, if you want to, you can say, let's go ahead and use Max for Mental Ray. And what's going to happen is, for example, Mental Ray extensions will be turned on in the preferences. I'll show you those in 1 second. Layers will be by object, and so on. The material editor will use the architectural and design shader by default. We're going to be going over that in later part of the first part of next week. But you get the idea that a lot of these default settings within the application will be defaulting to Mental Ray. And this is something that if you do have the gumption to be switching to Mental Ray, I would encourage you to do this. Obviously, you can change the preferences and the hotkeys and things like that after the fact. But if I go ahead and do this, and by the way, these design viz ones are kind of to set up Max like Autodesk Viz, that other sort of little brother to 3ds Max. I'm not going to get into those. I'm going to specifically stay up here with the Max Mental Ray setting. And let's go ahead and actually apply this. So it's going to go ahead and load this entire scheme. And in this case, you're going to actually see this horrible color scheme come up. I don't particularly like this color scheme, as you may or may not have seen, but this is something that you're going to have to restart Max. So as I exit out of here, and I'm going to relaunch Max, now what's going to happen is 3ds Max is going to want to work in Mental Ray. All the settings are going to be defaulting to Mental Ray. The Mental Ray rendering engine will be the default, and so on. We're going to get into the specifics of what just happened as we talk about things like lights and shaders in subsequent weeks. But to just get started this week, and God forbid I work with this horrible color interface, I'm going to go to Customize Interface. It did load the entire settings for all of this. So for keyboard, I am going to have to load back my own hotkeys, and my color scheme, I'm going to go back out and load my colors that I've actually used. A little side note, I'm actually going to be including these color schemes as well, and what these are, I kind of made these. It took quite a while actually to make these. This isn't something that you can do with just a couple minutes time, but I'm going to be providing these. It's actually a way to make 3ds Max either look like Autodesk Combustion, or in this case I'm going to make it look like Autodesk Toxic and use that color scheme. So once I've gone ahead and applied this, now I've got my hotkeys back, I've got the color scheme the way that I like it, and as we start to build things and use, for example, the material editor next week, you can see that the architectural and design shader, for example, is the default. Again, this isn't a class talking about lights, but if I just throw a light out there, you can see that it's defaulting to ray trace shadows and so on. So Max is actually really now set up to use the Mental Ray rendering engine, and as you can see, if we go ahead and hit render, it's going to actually be the Mental Ray engine. Now I'm going to bring up that castle scene one more time and just talk about the next thing, which is a really phenomenal feature called distributed network rendering. So to talk a little bit about distributed network rendering, I want to first take a little side note and let you guys know about a white paper that I wrote a couple of years ago, and this thing gets updated periodically. Visual Z is my website, shameless little plug there, but if you go into my training section, and down here to the Down on the Farm paper here on the right, this is actually a PDF that I wrote and distribute for free. You can see here it's 25 pages long, and I warn you, this is not exactly edge of your seat reading by any means, but this is actually just a document that I wrote to sort of highlight the features of network rendering, and specifically an application that 3ds Max ships with called Backburner. So again, Down on the Farm is just a play on words there of render farms. Network rendering with Backburner is, you know, the topic of that paper. However, what I'm about to show you with Mental Ray is something completely different than network rendering. Now, to be clear about this, it takes advantage of a network of computers, but it's not the same thing. And the fundamental difference between that is when you do a network render with Max through an application like such as Backburner, what you're basically doing is assigning each computer on your render farm one frame at a time. So say, for example, I have 3 computers. One machine would be rendering frame 1, another frame 2, and another frame 3, and then the first machine to finish its frame will be assigned frame 4 by the network render management software. So hopefully, if you're not taking advantage of network rendering, I encourage you to look at that paper and start network rendering as soon as possible. And there's even some documentation in that Down on the Farm paper about why you would want to network render even if you only have one computer. I'll let you guys go get that paper. It's also, I believe, in the FX PhD resources area. But getting back to distributed network rendering, if I just go ahead and start rendering this scene out, and right now I'm just using a Xeon processor, what you can see here are these little squares that are going around, and that indicates that we're using Mental Ray as our renderer. And those little squares are called buckets. And the fundamental difference between a scanline renderer and a bucketed renderer like Mental Ray is that a scanline renderer has to load the entire scene into memory. And you know, when you've seen when it draws those lines down the screen, it's doing, those are called scan lines. So basically every texture and every model is loaded into memory and then it's rendered. Now if I bring up the render dialog here and look at the renderer, what we've got here, and I'm going to go into these in a little bit more detail, but I first want to talk about this bucket width right here. So if I made this bucket width, the default of 48 is a 48 pixel by 48 pixel square. If I made this, say, 24, let's half that, you're going to notice that the buckets that are actually rendering are smaller. Now, this is a way to save a little bit of memory in Mental Ray. And that's not to say, well, you know, let's just make these buckets as small as possible, because there is going to be a trade-off like anything. In general, and I repeat, in general, the smaller the bucket, the less memory will be required, because what's happening is Mental Ray is only loading what it needs to per bucket. However, and that's a big all caps, however, just coming through here and saying, well, let's just then do a bucket width of maybe like 4 pixels. That's going to create so many buckets that it'll actually probably start to slow you down. So you can see here, and I'm not going to even bother letting this finish, we have so many buckets loading and rendering that it's not going to be productive workflow. So I'm going to cancel that render. In general, and again, there's no exact science to this. In general, I would say leave the default to be 48 pixels, and that's going to be a nice average where you have a fast render and also a low memory overhead. So you can see here with the machine that I've got going, this is a Xeon. It's a hyper-threaded Xeon machine, so I've got 4 virtual processors in here, and these are actually the 4 threads or the 4 buckets that are going around right now. So again, this scene, not the best thing in the world, but it's taking 9 seconds to render. However, what we can do is, I've got a couple of other computers here waiting to render, and what we can do is go into the processing tab of MentalRay and come down here to the distributed bucket rendering tab. Now this is clear by default, and this is how your Macs would default and install, with no machines here. But what we can do is say, okay, we are going to go ahead and distribute this render. And in this case, I'm going to, and this is a one-time setup here, I'm going to say, let's add a machine named Angelina. And let's add another machine called Stable. Now, something to point out here, you could be using IP addresses if you are prone to using fixed IP addresses, or happen to know that. I'm using machine names because I'm actually using a DHCP for my network, which essentially means that all of my machines are getting their IP addresses assigned automatically by my network hardware. So in this case, I do want to use machine names, but I could be using IP addresses as an option. Now you'll notice up here a file that's being edited, and it's actually called max.rayhosts. And that's actually just a text file that's being edited as we work here. It's kind of like a preferences for MentalRay, but it's really just specific to the distributed bucketed rendering. And that's really all there is to it. If I go ahead and hit render now, what's going to happen is you'll see up here it's translating the scene, and now there's actually more buckets throughout my render. And now it only took, for this, only about 8 seconds. So it was actually not a real, incredibly dramatic difference in this scene, and let me explain why. This scene is really pretty basic. It's fairly straightforward. Not a lot of geometry, not a lot of bells and whistles like caustics and lighting effects and ray tracing and things like that. So the scene is going to render fairly quickly on one computer. When I hit render and I'm doing a distributed render, what happens is there's an upfront actual process where it has to write that MI file across the network to multiple computers, as many as you happen to have here. This will be, I believe, up to 8 CPUs, and these machines need to be Windows XP Professional. They won't be. You can't have these machines be XP Pro, and that's just a limitation that Autodesk has set, and also Mental Images for this process. Before I forget, one of the things that differentiates this distributed bucketed rendering from network rendering is that limitation. So I could have as many machines in here as I want, up to 8. However, when I use network rendering with Backburner, I have unlimited resources to use both Scanline and or MentalRay. And that's something that happened relatively new, and I think Max 6 or 7. That's relatively new to me anyway. I've been using Macs for quite a few years. But that's a really great feature, is that you don't have to have a financial burden to buy tons of licenses of MentalRay anymore as you used to in the past. So with 3ds Max anyways, it's free unlimited network rendering, and this distributed this distributed bucketed rendering is going to be limited to 8. So not a huge limitation. It's really a phenomenal workflow to have this extra horsepower. While I'm talking about it, this distributed bucketed rendering option here for distributed maps, with this off, it's actually a little bit misleading, this nomenclature here. With this flag off, it actually does distribute the maps. And what's happening is basically every texture map in your scene is getting written across the network to your other network render machines for bucketed rendering here. if I have this flag enabled, what that essentially means is that these other machines, like Angelina and Stable here, they have access to all of my texture paths. So say, for example, I had all my texture maps on the R drive or the Z drive or the X drive or something on a network, and every machine had that same drive letter or share mapped to it. By enabling this, it's going to save you a little bit of that upfront time, because all of those machines already can see those textures local to themselves. And by that I mean local, network drive share. So say, for example, if I bring up this and I have, this is a RAID system that I have. Maybe my RAID drive or this N drive, these are systems elsewhere in my facility, but every computer might have access to this R drive, for example. Well, that would be a way, and if that was the case, I could just say, go ahead and use distributed maps rather, and that means every machine will look to that drive because it has already been mapped. So with that off, it's going to actually be copying the files across the network, which will technically be a little bit slower. So that's going to be a real fundamental, and that's basically all there is to it, is to get a lot of extra overhead horsepower. You just enable distributed bucketed rendering, and I can just pretty much leave that on, and that is an attribute that is saved with this max file. So if I go out and I'm doing, say for example, let's just really crazy put a, I'm just going to use a standard max material here, and again, I'm not turning this into a lecture about materials, but I just want to show you that if I take this entire house model and apply this material to it, and this is just house temp, and let's make it crazy ray traced reflection to slow things down here. So now we've got basically this chrome house without distributed rendering. This is probably going to be a little bit painful. And it's not too bad. I've got a nice fast machine in here and it's going through, but the ray tracing is slowing it down a little bit. And again, I'll just let that go ahead and follow through. So our wonderful chrome mirror house there, not the best thing in the world that I've ever rendered, but that took 18 seconds to render. If I go ahead and turn on distributed rendering, even just with 2 extra machines, and those are just Pentium 4s, by the way, they're not actually as strong as the machine that I'm using here. Now it wrote that file across, my local machine started really rendering it quick, and then the other ones kind of catch up, and now you can see that, you know, again, we've got extra horsepower means more productivity. Now the last thing I want to really touch on this week is a important thing. I'm going to go ahead and leave distributed rendering on for these last few tests. And if I go back to renderer, I want to talk about this very first dialog up in here. And this is a thing called the samples per pixel. Hopefully you've used anti-aliasing. Before I move on, I'm going to actually just apply a sort of a dumb material to this thing and call it standard. So we can look at this without all that chrome. And if I go ahead and do another render here, you can see that I'm getting a little bit of sort of jagged edges here, and it's not too bad. If I go ahead and zoom this image in, I'm just using the scroll wheel on my mouse to do that. You can see here we've got a little bit of sort of jagged edges, and along this railing, it's not the best anti-aliasing in the world. Now I'm back zoomed out at 1:1, and you can see that it looks fairly good, but this roof line, for example, is a little bit jagged, and what that is a lack of anti-aliasing. Now, the way that Mental Ray works, and most of the distributed, most of the bucketed renderers like V-Ray, Final Render, and Brazil, for example, they all have this minimum and maximum sampling quality. And what's happening is it's basically sampling contrast, and that's set up right below here. In the beginning, I would encourage you to just leave these values alone for contrast. But what's happening with that, let me just bring up that dialog again, is that, say for example, this area of neutral gray here, there's such, between this pixel here and the one right adjacent to it, there's no contrast. They're exactly the same color almost for all intents and purposes. So it's going to use this minimum samples to do the anti-aliasing there. In an area here, for example, where there's high contrast between this dark gray and this light gray, it's going to look to use the maximum value. So this is a way that you can maximize, or optimize rather, Mental Ray to do faster test renders And then ultimately, when you're ready to do your final rendered image for production, you can up that quality. So the way that this works maybe in production is to say, let's have this minimum at 1/16 and our maximum way down here at 1/4. And what that's going to do is render a much faster version of our scene at a loss of quality. So you can see here, we see the same amount of lighting in our scene, we see the same amount of materials, and nothing's really changed, but we're taking an obvious quality hit. However, that quality hit got us this image a lot quicker. So if I were to just crank this and maybe say our minimum 1 and maximum of, say, 16, now our image is going to look quite a bit better, but take a little bit longer. And this is one of the most fundamental things about mental rays, often maybe confusing points, is that sometimes there's a point of diminishing return in that, say for example, I wanted the highest quality image. That's not something that you're going to want to do is just crank this up to 1024 by 1024. I've never even done that. I'm not going to want to hit render because I don't even know how much memory that would take. That's probably a little bit of a wasteful setting. There's no real right or wrong answer to this. A lot of it will depend on the resolution that you're rendering. Say, for example, I was going to do a 1080 HD render and go back to rendering. I might want to up this to maybe 4 and 16. Generally speaking, for my own personal use, I've been using, I try to get away with like 1 and 4 for video resolution. And if I am doing HD, I try to get away with like 1 and 16. Now let's take a look and see how that looks. Our image is by default here zoomed out to half resolution, so let me just zoom our window here, and I'm going to roll the mouse wheel once. So now we're at 1:1. You can see here our HD frame is actually rendering through. All those buckets are going on multiple machines, and as I said, that setting of 1/16 is actually pretty good for high contrast areas. And I'm looking at this edge right down here, and I'm kind of checking out that horizon line over there, and so on. So again, there's really no right or wrong to this. I'm seeing a little bit of aliasing right up here in my window ledge, but that's not something I'd necessarily worry about for today's sake. But I just wanted you to be aware that this setting here of samples per pixel is maybe the most fundamental critical thing to understand about every single render that you do with Mental Ray. I'm going to drop this back down to say 1/4 and 1 for my test renders, and again you're going to get a pretty good idea of what the thing looks like, but it's going to happen at a lot quicker pace. So this is something I want every one of you to kind of play with and take advantage of. Another feature that this kind of works hand in hand with is the filter type over here. And without getting into too much detail about this, what this basically does is it's a way for the samples per pixel to look to neighboring pixels. So if I say I have a box type, which is the default, and you can see here it's kind of the lowest setting. That's not to say it's a bad setting. In fact, I try to use that as much as possible. But what box means is essentially you have, in the case of a pixel, let's say for example, I'm going to pause this and actually open up a drawing program so I can elaborate a little bit. Now, you really didn't think I was going to open up Photoshop, did you? Come on. If you know me, you got to know me better than that by now. Anyway, to talk about that box sampling and to just jump into Max again real quick, what I'm talking about here is this filter type. Box, what it does is essentially looks at a pixel, and then it's going to look to the neighboring pixels up, down, left, and right. So if I have this representing multiple pixels, and this is the pixel we're talking about, the only ones that will be considered in box sampling is this one, this one, this one, and this one. What we're going to have is these pixels will be ignored over here. And that's not necessarily a bad thing, it just means it's doing part of the work. As we move up to something like Gaussian, what we're going to do is actually get all of the neighboring pixels to look, or to be looked at when considering anti-aliasing. And here you can see how many out that it's going to look. So in the case of box 1 by 1, what's happening is something like I had just pointed out. So let's just do this real quick. In the case of box, it's going 1 pixel out in up, down, left, right directions, or X, Y directions. Hopefully this is all the tech you need about this, but back into Max, Gaussian at 3 by 3 is going to be slightly smoother anti-aliasing. even with the same samples per pixel. So these two settings over here between samples per pixel and filter type are going to kind of be a give and take. And this is a little bit of some of the stuff to not so much carve in stone and say always use these settings at this resolution or always use these settings with these shaders or what have you. But these two things are going to work very much back and forth and hand in hand with mental ray's quality for anti-aliasing, and it's very specific to anti-aliasing edges. Just moving down here a little bit and to wrap up for the week, this bucket order of Hilbert, there's other ways that you can do this, and for the most part it says here at best. There are specific things that I'll point out in later episodes of the class that are very much dependent on Hilbert being the bucket order type. For example, if I just said a spiral bucket order, and let's just switch this to a smaller res render here, you can see that gee whiz, it's actually going in a spiral. And there's nothing faster or slower about this. I just wanted to point out what that is. I would encourage you to leave this set to Hilbert for other purposes that we'll get to later. And this frame buffer type will be the last thing in closing this week. For the most part, what you're looking at here with integer of 16 bits per pixel, that means that you can actually work in a linear color space with up to 65,535 values of red, green, and blue. Now I'll go a little slower there and actually pop back into combustion to show you what I mean by that. Let's just get rid of all these brush strokes. If I have color values in combustion, let's say for example, let's bring up our color palette here. If I'm using RGB with 0 to 255, that's what's called 8-bit color space because our red, green, and blue uses 0 to 255. However, what you have the option to do, I'm going to go to a 16-bit color space. In Max and in Combustion and other applications out there, what you have the ability to do is work in a color space that allows for 65,535 to 0 for a total of 65,536 colors per red, green, and blue. And instead of the 16.7 million colors available in 8-bit color space, this is actually giving you 281 trillion colors available in linear color space. And while that might be a hell of a lot of color, there's still room for more beyond that. In the frame buffer type within Max, you can actually set this to work in a full 32-bit floating point color space. Now, before you get too excited about this, and everybody out there is really up on EXR and things like applications like Nuke and Toxic and things that are really taking advantage of floating point color space, and it is, but don't get me wrong, a very exciting and interesting new way to do things. I would encourage you to only use this if you are going out to a floating point format like EXR, OpenEXR. So if you're not rendering out like that, and say, for example, rendering Targas or PNGs, or for example, I would recommend staying in 16-bit linear color space, even if you're only rendering out to, say, 8-bit. Now, you might just think, well, let's just go to floating point because it's the new kid on the block and everybody's using it and talking about it. I want to be really clear about this, that it does use more memory, and if you don't need floating point color, then it's going to do you no good. In fact, it'll do you harm to switch to floating point color here. So I would encourage you to leave this at 16 bits per pixel for maybe all your test renders and whatnot, and then if and only if you're rendering out to something like the OpenEXR format, to switch this out to the 32-bit. So that's going to be a really important thing as far as when you're ultimately rendering out frame types. Let's put this back to box. Let's get this put back to like 1.4 for our test renders. And that's about it. The last little bit here, whoops, under processing, under the translator tab, I will point out in closing here, there is a way to specify how much memory is set to mental ray. And I wouldn't just max this out to how much RAM you have in your computer. I would try to find a balance. What this is basically going to do is leave some memory for things like 3D Studio Max and things. So what I've generally been prone to do is balance this between, let's say, 1,500 megs of RAM, and then also balance that between a potentially smaller bucket size. So again, there's a lot of information that I just hit you with. And again, mental ray is certainly nothing to shake a stick at. hopefully that's why you're here. You know, this is going to be not a 101 class by any means. We're going to be getting into the nuts and bolts and the nitty-gritty of all this materials, lighting, and rendering in Mental Ray. Hopefully that's why you're here. I encourage you all to stick around for next week. For those of you that are checking out the class this week and thinking about taking it, you've got one more week to check it out. Something that is worth mentioning also is that for those of you that do stay through to the class, there is going to be a Rumble, and all the people in my Max 201 class are actually going to be kicking the asses of all the other classes. So I want you to be aware of that, and when you're making your decision, hopefully you join me for the rest of this term. That's it for this week. I hope you did enjoy week 1. I'm really excited, if you can't tell already, for FX PhD. And my name is Gary Davis, by the way. Looking forward to week 2. I'm looking forward to the rest of the weeks. If you have any questions, by all means, please fire away in the forums. I'm there to answer you and also to ask my own questions. Hopefully we can bounce a lot of ideas and information off of each other in weeks to come, and I look forward to it. Thanks again for your time. For FX PhD, I'm out of here.